is Dr. Holt. This video is on projectile motion. In this first video, I'm only going to be talking about an object that is thrown vertically from the ground level. When doing any type of projectile motion type problems, we're going to be dealing with these three basic equations. Now, these are written in vector form here. What I generally do is rewrite them as y is equal to the initial position plus the initial velocity times t minus 1/2 9 times 9.8 times t squared. Then I have this one here, velocity at some time interval is equal to the initial velocity minus 9.8 times t. And again, these velocities are in the y direction only. And then my final velocity, or some velocity at some time interval, squared is equal to the initial velocity squared minus 2 times 9.8 times the change in my y position. So we'll be dealing with these three equations when dealing with something when it's traveling vertically. Now, when you get into the horizontal component, one thing you're going to notice is for the majority of the physics problems, and especially all the physics problems that we'll be doing in this class, that we will have no acceleration in the horizontal. So all we're really going to be saying here is the change in the position, or the change in the horizontal position is equal to the velocity, which is going to be constant times the time interval. Now, a couple things. These are special notes you need to pay attention here. The velocity in the y directions. So when you throw something up, I'm going to talk about an arc. If you throw it like at an angle, it's going to go up here like this. It's going to go like in a parabola. At the very top, when it reaches the very top, the y component of your velocity will be 0 at the highest point. However, the horizontal is not going to be. The horizontal, as it travels all the way through this parabola, will always be the same all the way through. So when it's launched to when it hits the ground, the horizontal velocity will be the same. Alright, to kind of clarify things, here I have an object. It's going to be launched vertically with initial velocity of 49 meters a second. So it's taking this ball here, it's going to be launched at 49 meters a second at time equals 0. Right when it leaves my hand at time equals 0, the acceleration immediately is going to be 9.8 meters per second squared. So I'm going to be talking about, I set this at the table, have my time here, my velocity here, my acceleration, and my position. And this is going to represent the change in position from different time intervals. Excuse me. So this is what we have initially. Now let's go to time equals 2 seconds, or excuse me, time equals 1 second. At time equals 1 second, my velocity now has decreased. Now, since my acceleration is 9.8 down, you notice my velocity has decreased exactly 9.8. I start with 49 here, I've gone to 39.2. So every 1 second, my velocity will decrease by 9.8 meters per second because my acceleration is 9 meters per second squared. I'll come down here and I'll look and see what's changed. So when t is equal to 1, my velocity has reached 39.2 meters per second. My acceleration will never change. It's going to be negative 9.8. My position now, I've gone up 44.1. And again, this position here is based upon just using these equations right here. Using this specific equation here, you can find your position in the y direction. Alright, so now let's see what happens when I get the time is equal to 2. When time is equal to 2, this velocity should decrease by 9.8. Well, it did. I went to 29.4. Again, my acceleration has stayed the same. So we'll come down here, we'll look at the table. At time is equal to 2, my velocity is 29.4. My acceleration has stayed the same. My position has gone to 78.4. Now, I should have talked about this in the previous problem. Here I can talk about it now. Between 0 and 1, my change position is 44.1. Now my change position is 34.3. I'm getting that from 78.4 minus 44.1. You notice my change position is getting smaller as the time goes up. And the reason for that is because my acceleration is negative and my velocity is positive, so my velocity is decreasing. Let's go to another time interval. T is equal to 3 seconds. Again, my velocity is decreased by 9.8. So my position will be here. My acceleration, again, is still going to be the same. We'll come down here and look at the table. At t is equal to 3, velocity 19.6. Acceleration the same. My position now has gone to 102.9. and my change position from t is equal to 2 to t equals 3 has gone to 24.5. At t equals 4. At t equals 4, my velocity now has reached 9.8 meters per second. My acceleration is down, going down, or negative 9.8 meters per second squared. Well, again, looking back at the table, at t is equal to 4. Again, these are the velocity 9.8. This has stayed the same. My position is 117.6 meters vertically, and my change position between here and here would be 14.7. And now we'll go one more. At t is equal to 5. At t equals 5, my vertical velocity has gone to 0. And the reason why, because at 4 seconds I had 9.8 meters per second. My acceleration, again, negative 9.8 meters per second squared. So in 1 second, my vertical velocity has gone to 0. At this point, I've reached my maximum height. That's my maximum height at this position. We'll look at the table. At t is equal to 5, my velocity in the y direction is 0. My position is 1 to 22.5, and my change position has only been 4.9 meters. And now, at this point, we're going to start going down. As we go down, our velocity now is reversed and going the opposite direction. It's going to have the same magnitude as it did at 4 seconds, but it's going to be having a direction of pointing down. Go back to the table. At 6 seconds, my velocity is negative 9.8. My acceleration is negative 9.8 meters per second squared. My position has gone to 117.6. And you notice it's the same position as what I had at 4. And my change position now has gone to negative 4.9. Because I'm starting to head down. We go to t is equal to 7. My velocity magnitude is increasing to 19.6 meters per second, but it's going negative. My acceleration would stay the same all the way through this path. We go to the table. My position now has gone to 10.29, and you notice that's the same position as I had at t is equal to 3. My change position now is negative 14.7 between here and here. At t is equal to 8. At t is equal to 8, my velocity is increased to 29.4, going in the negative direction, or the negative y direction. Go back to the table. At t is equal to 8. Negative 29.4 meters per second is my velocity. My acceleration is still the same, negative 9.8 meters per second squared. My position here is 78.4, which is the same position I had when t is equal to 2. And my change position is negative 24.5. And you notice that you're seeing similarities between these, just in different direction, that's all. And at t is equal to 9, my velocity now has reached 39.2 meters per second going down. We'll now go to the table and look here. Again, velocity negative 39.2, acceleration negative 9.8 meters per second squared. My position is 44.1, which is the same position I had when t is equal to 1. And my change position is negative 34.3. And then the final one, at t is equal to 10, I reach my maximum velocity going down of negative 49 meters per second. We'll go back down the table and look at this. And you notice my position now, I've hit the ground at 0. My change position here is going to be 44.1. Alright, now I'm just going to back up and let's go through the time interval. Step through this very carefully and watch what happens. Just follow along with the dot as I go through the different times. So t is equal to 0, t is equal to 1, t is equal to 2, t is equal to 3, t is equal to 4, t is equal to 5, maximum height was reached, t is equal to 6, t is equal to 7, t is equal to 8, t is equal to 9, t is equal to 10. I hope you notice when I do this that you notice how much the change position is increasing. Because from here, notice from here to here, watch this, from t is equal to 8 to 9 to 10. Those values are increasing. Alright, it's a simple little video. I hope it kind of helps you understand the relationship between velocity and acceleration, and the relationship as you go up, and the relationship when you come back down. There's a direct relationship here as far as the magnitude of the values. They're in opposite direction, but then the magnitudes will be the same. Alright, best of luck.